Okay, hello guys. Thanks for joining this session. I'll be explaining about this question called Hamming codes. Well, this is a question, and I've broken down it for you. What we're gonna do. So first thing, we have these three inputs here, N, D, and D. Uh, N is the number of results we need to get. B is the representations of numbers in how many bits. In case here 7, you need to turn 1 into a binaries of 7 bits. 2, this 1, 0, 0, 0, 1, and 2 will be 0, 0, 0, 1, 0, and so forth and so on. And then D is a Hamming distance. Here, what is a Hamming distance? Hamming distance is a difference in bits between two binary numbers. For example, here you can see this is 1, this is 7, and then the Hamming distance would be this difference here. 0 and 1 means one distance, 0 and 1. One distance total, there will be two distance between 1 and 7. That is basically the concept here. So what we need to do is that we need to list n number of results, n here, and then the Hamming distance between all number in the result set has to be at least d. What do we do is that firstly we set 0 as the default one, then we find the next number that had d distance with 0, then we keep on finding the next number that has d at least d distance with 0 and a. A is the previous number, and then we name it b, and then the next one we find is that the next number that had d distance with 0 and a and b, and so forth and so on until we have n results. So keep on finding that every new number that will have a Hamming distance of at least d with every single previous result. Okay. So this is a code part. Firstly, we take in all the inputs. I rename them here. You can see this is actually N, B, and D. So I here make a array list to store all the results since we need to compare with every single one of them. Then firstly, we'll initiate the first number, which is 0. It is default for every single case. Then we'll keep on finding, start from the number 1. Since 0 is already added, we'll directly start from the number 1. So until we have n results, this is n. Until our result set had as many numbers of results as n, we keep on checking whether the next number has d distance with every previous result. So we will keep on checking. I'll show you the checking part later. And then after finish checking, we have enough result. We'll simply print it out. Remember that there's a little tricks here that every 10 result you have to print a new 9. Otherwise, just give it a space between every result. Okay. So this is a checking part. What do we check? Is, as I said before, you simply check from every single previous result. This is my result array. We look from the first one to the last one, check whether the distance between the number we want and all previous result has the distance or not. And this is how we check the distance. I simply convert the number into binary. How I do it is that I modular the number with 2, then I get the modular which is supposed to be 0 or 1 only. Then I compare two numbers, whether are they different. If they are different, I add a distance. It's like 1, 1, same, then 0, 1, distance, I'll add 1, then go on, so it will be 2. So keep on adding. This is actually the method to convert a number into a binary. And I guess that's about it. Okay, thank you.